Very good. Well, welcome to the November 9th, 2021 session of Tangerine SDR and Hamsa technical session. My name is Dave, KV0S, and this week I've been, I was busy in a Zoom field trip in forestry, which was quite interesting. Had videos from across the US and even one from Hawaii and one from New Zealand. So that was quite nice. It was a lot better than flying halfway around the world to see, although it'd be nice to do that once in a while, but got to see some forestry in New Zealand. So I did that, and I've been working on continuing with dongle radio work and making some progress, but still not completely there. I did get a whisper transmitter this week, multi-band transmitter. So it's working quite well. So I'm happy with that. And that's my week. So next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thank you very much, Dave. Continuing to move things along here, working on my LSTID paper. I worked on that over the weekend. I got news that the Hamsa workshop NSF grant has been recommended for funding. So it's in the final stages of being awarded. We're looking at having the Hamsa workshop in Huntsville, Alabama now. So I'm working on logistics for that right now. I have a meeting regarding that tomorrow. So hopefully we'll get that squared away. We're looking at having at the US Space and Rocket Center. And it looks like there's some interest from local hams as well to support it, possibly doing some things like a special event station or other things like that. So that's all coming along very well. Let's see, I also finally got my magnetometer working inside, basically on the test bench. So our lab equipment manager, Majid, put it together. And then with Dave Witten's help, I followed his directions on his GitHub. I was able to get it running. So hopefully I emailed Jonathan Rizzo today, and we are going to, hopefully he'll be able to come over this Saturday and we can get it in the ground. And then we also had a nice banquet here at Scranton on Friday night where we awarded Jonathan Rizzo the University of Scranton Department of Physics and Engineering Excellence Award. So congratulations to Jonathan Rizzo. W2NF, back to net.
Fine business. And next on the list, we have Dave, KD0EAG. Go ahead, Dave.
Well, I've been working some on magnetometer software and some on setting up a project for Amartya, who's something that's doable. And so that's been taking up my time. I did want to ask Nathaniel if you're going to need to make me, for me to make you an account for the Linode, yeah. Just send me what you want it to be, and then I'll make it, and then you should be able to connect to it. That's it for me.
Okay. Next on the list is Dev, KC3PVE. Go ahead, Dev.
Hello, good evening, everyone. So we have a good start here in Scranton. I don't have not much to convey this week, I should say. All is well, but nothing very significant. Thank you.
Well, fine business. And thanks for sending those reminders. They're very helpful. Next on the list is Bill, AB4EJ. Go ahead, Bill.
Well, thanks, Dave. Good evening to the net. My work this week was pretty limited because I was at my daughter's house in Orlando all week working on having a big celebration for my son and his new wife. This is the first chance we had to have a reception for them, even though they got married in March of last year. So we had a big blowout all through the week. Although I did work a bit on analyzing the PSK data for TID, and I'm working a little bit with image processing to get it in such a shape that we can do some image recognition and looking for TID signatures by doing feature recognition using TensorFlow. And so I found that there's a little bit more structure, and Nathaniel's aware of this. There's more structure in the data than what we had realized before by virtue of just being able to, I've got it to where it displays different levels of, the amount of propagation by distance, by color code and some things like that. So it's interesting to look at, but more to come on that later. Back to Ned.
Well, fine business, Bill. And next on the list is another Bill, N8ET. Go ahead, Bill.
I don't have too much to report. Let's see. You hear me all right?
Yes, just fine.
Okay, yeah, my audio. I think I finally figured out what the problem with the audio was, but been fairly inactive the last couple of weeks and just get back into it. So on here tonight to see what's been going on. I'll just sit and listen.
Okay. Next on the list is David, N1HAC. Go ahead, David.
Oh, hello, everyone. Missed last week's because I was busy with machining for some solar panels for Yeoman's, one of Yeoman's projects. And that seems to be going well. But I've also this week been doing a little investigation about using our AM Doppler receivers for WWV work. We may be able to do something on the low end of the band. Phil Erickson has been interested in that. He's hosting one of our receivers, so he was kind of pushing along on that. So we'll see. We may be able to contribute to that project. Back to Nat.
Well, fine business. And next on the list is David Waugh, KE8QEP. Go ahead, David.
Hello, good to see everyone. Not much to report here. My grand plans of spending more time comparing the magnetometer data from Bob's station, which is 10 miles from mine, hasn't been going as quickly as I hoped because there have been other distractions. But I think that's it. Back to Dave.
Okay. Next on the list, let me see if I've missed anybody, would be Hillman Kim, KD2MCR. Go ahead, Hillman.
Yeah, good evening, everyone. Yeah, just like Dave McGaw mentioned, we've been pretty busy working in a machine shop that one of our engineers has. We're working like workers in a production line, doing the same thing over and over. Our cargo has finally been picked up and it's on the way. I just got a notice. So the instrument that we're building is going to be deployed in Antarctica. So that's part of our Antarctic project. But otherwise, there's not so much to report in relation to this Hamsa project. So back to Ned.
Well, fine business. And next on the list is James, KG4 DSG. Go ahead, James.
Good evening, Dave and the group. Not much going on around here, just listening in. Back to the net.
Okay. Next on the list would be JWB8 SBI. Go ahead, Jay.
Oh, previous is what James just said. Nothing really new here to report, just checking in to keep up what's going on and hopefully learn something new. So 73, everybody. Happy Veterans Day coming up here to all the veterans out there. Take care, stay safe. Back to Net.
Well, fine business. And next on the list is Jim, K4BSE. Go ahead, Jim.
Good evening, all. Not a whole lot on this project. I did note that Dr. Frizzell is going to be presenting a program to, I think it's the GARS Club down here. I believe it's next week, isn't it? And
tomorrow night, actually.
It's what?
Tomorrow night.
Tomorrow night.
Yeah.
I'm hoping I can catch that, but I'm not sure about it.
I'm hoping the food is good.
The
only reason I go give talks at radio clubs is for the refreshments.
Well, I hate to tell you, Nathaniel, I used to be close enough to that club that I could attend some of their meetings, and they do have a few snacks available for sale there, but it's not great. So I hate to disappoint you, but
is it better on Zoom than in real life?
Yeah, it might be better on Zoom than in real life, especially if you lay in your favorites.
Yeah.
Let's see. I have not a whole lot down here. I have been kind of interested in the propagation issues recently, the CMEs, and what effect that might have. Haven't converted my grape over to the RF yet, because I would have done that, but kind of interested in watching what's going on with propagation right now, the way I've got it. We had some interesting events last week, and one of them I noticed last Thursday morning when it was still going on. I have a 80-meter net with some people about 100 miles from here, north of here, on Monday, Tuesday, Thursday, and Friday mornings, and it was just totally dead at 8 o'clock local on Thursday morning. Came back actually that hour, and that did kind of correlate with some things I was noticing on my grape records of that time. And just trying to coordinate them with all the exciting things going on the sun last week. So I've really just gotten started on that because I've been tied up on non-ham things. That's about it. Back to Net, K4BSE.
Oh, very good. And next on the list is Jonathan. Congratulations, Jonathan.
Hi, everybody. Thank you, Nathaniel, and thank you, Dave. It was a lot of fun, and it was pretty awesome. It was a great night. We had some good discussion, great food. They showed off the changes to the program, and they got some feedback on the on their engineering programs too. So it was a great night, and thank you again. This week I received the audio injector Ultra. That was the first high quality or 192 kilohertz sampling sound card for the Raspberry Pi, made by audio injector. It's a slim form factor, so it could fit the Pi Zero too. I wanted to try this one to see if it would actually work, if I would get better results. I was kind of wondering if it had something to do with the clocking. This one actually has an actual crystal where the audio injector isolated uses the onboard PLL of the Cirrus Logic codec. So all I need is a Raspberry Pi stacking header. I have one on order. I'm going to give it a try and see if that works, and I really hope it does. Otherwise, I'm going to have to use the audio injector stereo and just be limited to 40 kHz for the time being. Other than that, that's all I have. Back to the net.
Well, fine business. Next on the list is Jules, K2KGJ. Go ahead, Jules.
Good evening, list. Not a lot going on this week, except some NVIS experiments for 80 and 160 that I've been continuing. Still have to plot data on those, but nothing new in the magnetometer front. My 1 PPS interrupt seems to be quite reliable in producing the 86,400 samples per 24 hours as it should. And back to net.
Well, fine business. I did want to mention on the list, we had a fellow report that there is a PNI magnetometer installed in Minnesota. And hopefully, Dave, do you know more about this? Dave Whitten?
Jules, I'm not sure Jules doesn't know more about it, but Noel Pettit has been, he's got some other magnetometers and he's up north of Minneapolis a ways. It has one of these also now. Maybe Jules knows more about it than.
Yeah, he's basically he's got the RM3100. I guess at 48 inches below the soil. He's running a Python script for it. He also he's got an earlier magnetometer, a Falcon, which I believe is a FluxGate that is from an earlier program several years old. Plus he bought a single axis from Stefan Meyer of an FLC 100. I've got 3 of those here for making up a 3-axis FluxGate mag. But haven't been able to complete that project yet. But he's got one running currently. That one requires also at the same with a thermometer in a temperature sensor at the same depth as the RM3100, and that particular magnetometer requires an AD converter. It has a voltage output. I emailed him after I saw his comment today, asking what resolution of the ADC he had. He's running it on a Raspberry Pi, and I'm interested to see what he replies on that. So far, the first plot that I saw from the FLC 100 looked a little noisier actually than the RM 3100 plot, but that could be for a number of different reasons, including how he's averaging the data afterwards, so on and so forth. However, he does have a FluxGate, one of the medium cost, those things run about $160 a piece, the FLC 100, unmounted, that you just get the board and you have to make the interface, AD converter, et cetera, from there. And then he has the RM3100 and he has the older Falcon FluxGate. So he's got 3 mags actually running in the same location now. Go back to net.
Well, fine business, Jules. And next on the list, we have S&T W0EEE. And for those of you who don't know, that is the Missouri Ham Club at Rolla, Missouri S&T. I'm familiar, they're just down the road from me. And my son is an alumni in electrical engineering from that school. So with a PhD. And welcome, guys. And hopefully you'll find something interesting to get involved in.
Yeah, thank you. Ward Silver kind of introduced us to you guys. He was like, yeah, you guys should do it because Ward Silver's an alumni of our club. And we're just kind of looking to be involved in stuff because he gave us his magnometer because he was getting busy with some other stuff. So we're going to set it up here in Rolla and hopefully start getting some measurements and pies of our own. And if there's anything else we can do to be involved, we're all really interested and looking for stuff to do.
Well, Dave, KD0EAG, and myself, KV0S, are both in Columbia. So if you need any help, we can arrange to get together.
Oh, yeah, sweet.
So next on the list is, before Scotty talks, I want to mention Tom notified me that he was not going to be available today because of a conflict with some other meeting. So no Tom McDermott report. Scotty, go ahead.
So does that make me last?
Yes, that makes you last this time.
All right. Not a lot this week, but did do the ARDC. They had a seminar this week, more for, I think, for their edification than for ours, but it was interesting 3 hours. And I think Nathaniel was there too. So it was, I found it very interesting. And especially since we have some existing grants and are going to be applying for more grants. I did hear a rumor that the ARIA 10 chips might actually be available by the end of this month. Now that's scaring me a little bit because we have a big chunk of change. We put an order in for those. So Nona's been sick this pretty much this whole week, so she hasn't been able to do anything about it. But we need to check into that and find out where they are in the pipeline. But that's maybe some good news. I'm not sure. Maybe it lights a fire under us. I've got my magnetometer started here, and I wanted to show you guys what I think this is the best way to do the end cap. I don't know if you can see that.
Yep.
But that's a piece of that foam pipe covering, the black piece right here.
Yes, we can see
the
it.
board. Yeah, and then you pull the board and the black piece out. It's interesting that the board itself, if you put it in upright,
Writing's not that.
the magnetometer is too tall and it hits the curvature of the board. It hits the curvature of the pipe before the board bottoms out. So you really want to push the board up this way against the pipe. I don't know if you can see that, but you want to push it backside against the pipe, which means that you really need to take the, wherever it went, there it is. I'm going to take the piece of foam, and you can see it's kind of I don't know if you can see it's kind of mangled there, but that's where it touches the 3100. And
yeah, Scotty, the only thing you have to be careful of is that you don't upset the Z-axis sensor, which is the little vertical sensor sticking up. If you cut some relief on the foam or something for that.
Well, if you look in there, it just barely touches the foam.
Okay.
And if you turn it the other way, it pushes against the hard pipe. And
no, no, what you want that you want the way that we normally do it is the flat side against the pipe.
Right.
And the yeah, exactly. That's the way we normally do them.
And so that it fits right in here like so, just with hardly any effort at all. And it's flat against the pipe.
Yep, that looks good.
And then you put marks. I haven't done it yet, but you put marks here and here to show where it is. So if you ever have to take it out, you can slide it back in and orient it the same place. And then cap on the end and yada, yada. And then I wanted to show you this. I don't know if you've been able to find one of these plugs, but this plug is a recess. So that would give you the full size out here for the nut to go on. And it's pretty much flat. It's got a little bit of printing, but I think the rubber gasket would take care of that. It's just a couple little raised pieces. So this might be a better candidate for putting the gland nut in, so to speak, and then gluing it into the T. And of course, there's all kinds of different T's that have different threads here. If we can find something to thread right in, but I've kind of, I don't think that's going to happen because the threads are just not going to be compatible. With this, one drill, and you'd be all set. You wouldn't have any special parts or anything.
I've never seen those in any of our hardware stores around here.
But if I can if I can buy 100 of them, then we'll have them, and then you'll get them. So
yeah, I've seen them here. The thing is, Scotty, that would you be cutting that rim off, or would you be putting the connector all the way through, so it's actually inside the
inside?
Okay.
If it's small enough to fit inside, so the gasket would fit along the bottom flat part.
Okay.
Of this, the recess.
And it does fit inside, so it'll give you enough room to kind of lock the mating connector onto it. That's good.
The good news is the thickness here,
right,
of this is very thin. It's only 3/16 or something.
Yeah, that's important because then the thread depth is enough to put the nut on the other side. Yeah, good.
Because the problem I have with the other cap that I have, which is this one, the nut goes down inside here.
Right.
And to be able to hold that nut is problematic, and whether it fits is also problematic. And then of course you have to grind off the lettering on the outside, but that's pretty easy.
Yep.
Sandpaper. So either one of these would work, but I think this I think might end up being a little easier. because it gives you free access to the nut here.
Also, if you align your board at the bottom of the pipe so that it is square with the, so let's say that the Z-axis sensor on the board lines up with the T, then that gives you a reference point to set your basic north-south setting with it. And then you can do your fine tuning more easily rather than, start at some place that may even be east-west and then finally rotate until you get that thing in the proper position.
So my Z-axis would be up.
Yeah,
in this case.
yeah, right. So in other words,
I want to put the
line it up so that's up and the board is flat against it. Yeah, right, exactly.
Like that.
Yeah. Yep.
Okay.
That's the way you want to do it.
So if you don't do that, what's the implication?
Well, the only implication is that when you start to do your fine tuning by rotating it for minimum magnetometer reading on the y-axis, then you're going to have to, you don't know where you're starting out. You may have to rotate 90 degrees or more to get down there. Whereas if you have that aligned in that way, set it up initially with a compass
you want to
magnetic north.
This kind of north then.
Right. If you do that, if you do that initially, then you're fine tuning to get it into the minimum output for the y-axis will be, you won't have to rotate it very much.
So then you could just eyeball it this way.
Yeah.
And get close, and then only be a few degrees off.
Yeah, it just gets you close. That's all.
And the writing on the pipe provides a good frame of reference. I mean that's what I used. It's not perfect. It's not aligned, but it's a central line. So I just made aligned north with the writing on the pipe.
Yeah, and then rotate your board such that it's. Yeah, I get it. It is pretty tight, so that's a good sign. And then put it in about like yay.
Yep.
So the writing on the pipe is there. Board's there. I'm a little off, but.
Yeah, but that's the idea. Yeah.
Okay. So that could go on the instructions, and then the thing is, since we're going to be supplying all of the fittings, whatever fitting we get is the fitting we're going to give instructions for. So that's, if it's this one with the hole, or if it's this one with the other way, whichever one works, whichever one we find, we'll tune the instructions to be appropriate.
Yeah, like Dave Whitten said, I think I've seen one of those caps here in the store. They just had one in a box somewhere, but they at least locally, they're not very
I found this
common.
one at Lowe's,
Okay.
and I visited 2 different Home Depots and could not find this kind.
Right.
Only this cap. So
Yeah, Lowe's is where I saw the single one that I found here too, but haven't seen any since then.
Yeah, but it does have a part number on it, so I think it's possible we should be able to buy them if we wanted to buy 100 of them or 200 of them or some large number.
Sure.
I did buy a bunch of these little test cap plugs, and it's a very thin plastic, and I think it's for if you're pressure testing the PVC, you can glue these on and pressure test your plumbing system. There's a little bit of writing, but it's just a little tiny cap here.
Is it hard PVC?
What's that?
Is it hard PVC or is it like polyethylene?
It's a different material, presumably.
I think it's poly. I think it's polyethylene. Yeah.
Glues to the pipe.
Oh,
and
it does glue. It does glue though. It melts into the pipe. Like
well, I can test that this evening. I haven't tried that yet, but it's certainly smaller and it's closer, to the surface of the pipe. It's just a little. There's some other versions that have a little tab that you can use to. Well, here's another version, and it's got this tab in there, which I think would make it unusable. Because the idea is after you've, pressure tested, you can just pull this out.
Yeah. And these are at the Home Depot in the PVC department?
No, I bought these online to try out for this purpose, and then I forgot about them, and I haven't tried gluing them. But I'll check that out tonight.
Yeah, I've seen those in Lowe's, but just across the aisle from the regular PVC stuff, in with the drain and sewer pipes. But I have seen them at Lowe's.
I've had some people really wondering why I was spending so much time in their PVC plumbing section.
The guy at Lowe's came out and wanted to help me.
Yeah.
And trying to explain to him what I was doing, he just gave me this blank look like, what?
Yes. Are you a terrorist or what?
Right.
I want to mention Mike AAK jumped in, and so he's also here. Mike, you want to say hi? Yeah.
I'm sorry about that. I got distracted, forgot about it.
Scotty, I had a question going back to what you originally talked about, the FPGA availability. Well, I guess the first question, still no word on the Max 10, I assume.
No word on the Max 10. It looks like the ARIA 10 is going to come in before the Max 10.
Okay. Did you have a plan for like proof of concept on those or bulk buy, or what were you planning on doing? Or did you have a plan?
We bought 25 of them for prototyping. And
that order's already in?
That order's already in because, so we wanted to get it on the books because the rep says, until you place an order, I can't do anything to expedite anything. So once you get an order placed, then you can go in and say, try to put priority tags on it. And you know, in normal times that works. But in these kind of times, you know, everybody puts a priority tag on theirs, so it doesn't work so well. And then part of the problem is that I don't really want to get them in before I can use them, because the plan was to take the existing data engine, rip out the Cyclone 5 and 3 or 4 other things like the USB 3 and the gig Ethernet and put in a 10 gig Ethernet in place of it. And I think that's eminently doable. But is that where we want to go for, because that's going to end up coming out first because we can't get the Max 10s. So do we want to do that? I mean, it's because the problem is it's going to take up, well, we've already bought all the parts for the prototypes for all of the boards, except for the one part. So that means all the RF boards, all the clock modules, GPSs and everything, we got all the parts are sitting in the next room. I got to raise my insurance on the house because of the amount of parts in the next room. But so if we build the Max, if we skip the Max 10 and go directly to ARIA 10 and build the data engine Mark II with that, then we used all the parts for the data engine Mark I for the Mark II. Now, the RF boards and the clock module are the same. So they would be just shared between the two prototypes. That's not, but the data engine, we would have to buy the parts for the data engine Mark I again when we went to prototype that. And I think it's really important that we have a data engine Mark I. Regardless of what the limitations are of the Max 10, the cost is so much less that it's going to be the entry level for most everyone. And whatever, we'll do whatever we can do with it up to the limit of what the FPGA can do. And then you want more, you're going to have to pay a lot more, but it's going to be a lot more. So not everyone's going to want to pay that. So I think most people are going to end up making do with whatever we can do with the Max 10.
Do you have a ballpark delta between the bill of materials on them, between the Mark 1 and 2?
I don't yet.
Just a ballpark.
I mean, I'm guessing at least 50% more.
Really?
Maybe double the price. The problem is that you've got not only the FPGA, but you've got the support for the FPGA. We're probably going to have more RAM, and we're going to have the 10 gig Ethernet support, which is, so I don't really know the answer to that. And then you have to ask yourself, well, you don't want to scrimp on features on the Mark II, because if you're going to have a Mark I, you don't want to make the Mark II $100 more, but then not have enough features to really utilize the FPGA. Because if you're going to put this big honking FPGA on there, let's put enough memory, let's put enough support for it. And yeah, it's going to increase the cost of the board, but we already have the entry level one. So I'm not really worried about making this one cheap, because I want to make this one really performant. That's kind of where I'm headed. And if that's the wrong thing, please tell me now, because I'm thinking you're going to have the entry level, we're going to have that. And now the next step up is going to be performance is what you want.
Well, plus for the Mark II, I can't imagine that a Raspberry Pi is going to be enough compute horsepower to work with it. You're going to need a high-end desktop at least.
You're right.
You know, something like a couple, $2,000 or $3,000 a Dell or something like that.
Yeah. And I'm thinking you're going to end up probably sending out multiple streams to multiple computers, perhaps, because there's not going to be enough horsepower to handle a 10 gig stream. Because we can't, let's see, I'm trying to, if we have two channel boards, RF boards, we can pretty much fill an entire 10 gig stream. So that's going to be tough for a PC to keep up with.
And you're going to have network attached storage and on and on and on, and switches that can handle all of that. So
yeah.
And I guess your main customer for that is going to be like NASA, NSA. I mean,
well, so then
astronomy, radio astronomy.
This is funny because we've had contracts before with government agencies that say, well, you know, you're really not charging enough for this, for what you're giving us. And so I'm serious. They don't really, they can't come back and say, give us a bigger bill, but they can come back and say, are you sure? Are you really, is that right? Are you sure that that's enough? You know, and they kind of make these leading comments that lead you to believe that, you know, you're way underbidding this thing. Well, if we produce this thing at the cost point I think we can do, I don't know how fast we can produce them, but right now, not very, but still, it's going to be way performant for the money that you're going to spend.
Yeah.
And you're going to spend like the equivalent to, you know, the entry-level Flex when it first got $1,500 maybe, and you're going to get a 10 gig front end to a PC. You're going to spend more on the PC than you're going to spend on this.
Well, yeah, you're going to need about some of the highest end PC you can buy
with 10 gig ports.
Something like closer to a server.
Yeah. So, and I mean, the other alternatives you can say, well, instead of thinking about it that way, we could serve up 100 virtual receivers, 100 streams on 10 gig E. Right. So,
does anyone want that?
I don't know. That's a good question. But I mean, you're asking, well, what can we do with it? You know, nobody's asked because we don't have any hardware that'll do it. So if you had it, what would you do? I mean, my business partner and I have these discussions all the time, and he's kind of saying, well, why bother with all this high speed hardware? You know, what are you going to do with it? What are you going to do with those streams? Oh, I don't know. So then you have to kind of rethink your radio architecture, because it's not something that we have now. And so we have something new that you can do that you couldn't do before. So, and all these guys telling me, like Phil Harmon telling me, well, just give me all the data. You know, it's called software-defined radio, you know, software-defined radio. So like, we're really going to do everything in software. Go like, okay, you asked for it. Here's your data. All of it. Well, 10 gig of it. Good luck. But I mean, you know what's going to happen, that as the days go on, PCs get more powerful and cheaper, and memory gets less, and disk gets less, storage gets, flash gets cheaper, everything gets cheaper and faster and better. So someday in 2030, you know, you're going to have an i25 that will be able to keep up with this on a Raspberry Pi layout scale. Dreamer.
It seems reasonable.
I want my $35 10 gig E, you know, twice the horsepower of a current 12 core system on a little board, they big, you know.
How about a cluster of Raspberry Pis?
Yeah. It's like I was asking Gerald Youngblood back in 2006 when he first started building at SDRs. He says, well, why didn't you do this like 10 years ago? And he says, because PCs weren't powerful enough. They just weren't any. You can't do this on a 286, so you can't do it. Now that they are powerful enough, oh, wow, look at all the cool things we can do. And it's now the same thing. It's like nobody would have dreamed that I could feed a 1 gig even pipe to a PC and have it process all that data. I mean, 10 years ago, no, maybe 10 years ago, but 20 years ago, no. 20 years ago was about the beginning of the SDR, powerful enough computers to do SDR at all. So I don't know, because the theory is that they tweak on it, and the powers that be like Intel and AMD, they improve the system in small increments over a period of time. I mean, what's Intel up to, like 12th generation now, 11th generation? What's the Evo? That's the 11th, right? I think it is. Now they called it Evo. I don't know what they're going to call it after this, but every generation is a little bit lower power and a little bit faster and a little bit cheaper. And then what will happen is eventually they'll discover some paradigm shifting. They'll make some paradigm shifting change. Like when they went from a 286 to a 386, it'll be an architecture change, or it'll be a super cooled junctions, or it'll be optical. It'll be some paradigm shifting thing that'll give you an order of magnitude jump. And then they'll sit and they'll spin that and improve that a little bit at a time, because originally it'll come out and it'll be way too expensive. And you can get 10x the performance of an i9, but it costs $20,000 for the chip. So nobody buys it. But then they tweak on it and work on it, and they get the price down, and they learn how to do it. And then pretty soon, all of a sudden, i9s are gone and you got the new part and more performance. I mean, I look at it kind of like electric car batteries, right? There weren't electric cars in the 1990s because there weren't any lithium ion batteries that could do it like we have today. Yep. And they'll go lithium ion, and then they'll improve those, and then they'll go to lithium iron, and then they'll improve those, and then they'll go to some. I bought some batteries at the swap meet this past weekend. They're lithium sulfur batteries. Yep. They're primary batteries. You can't recharge them. But the guy gave them to me, so I said, well, what the heck? I'll take them and I'll play around with them and see what they can do. I have no idea. They've got some weird 5-pin connector on the top. There's supposed to be two 12-volt packs inside that you can do a series or parallel. But lithium sulfur, really? I mean, that sounds inherently dangerous right away. So what is it? Lithium lipo batteries are like lithium cobalt, right? Is it cobalt the thing that they use in the original lithium batteries?
Well, they still do.
Before they went to lithium iron.
Yeah.
No, they use cobalt still use a little cobalt, but it's a stumbling block.
So is it the lithium cobalt ones are the ones that they have trouble with thermal runaway and catching fire and things like that. So they have to be really careful. And the lithium iron batteries, like the ones I use, like the 123 batteries, I'm not to say you can't catch them on fire, but they're a lot less prone to that kind of. Yeah. I have no idea what lithium sulfur is. If I drove a nail through it, would it explode? I'm not going to try it. Maybe I take it outside and shoot it and see what happens. It says, probably do a little research online to see what I don't even know what, it's this 12 volts. I don't know how many cells that is. I don't know what the voltage, the chemistry is. But far be it for me to turn down something is free. So I told the guys, like, you put a free sign on it, it's like, a magnet. I was like, oh yeah, well, I got to take that, even if I don't have any idea what I'm going to do with it. It's free, so what the heck. But you'd be surprised what you find in the free box. Yeah. Like I'm trying to set up my bicycle with the TM D700, D710. So I'm going to have a 50-watt mobile on my bicycle. But the problem is if you mount the antenna on the trunk pack, it's too close to the radio. And as soon as you key down on high power, aside from radiating your backside, it shuts the radio off because it doesn't like getting RF into it, right? So if I hold the power cable, if I put my hand over the power cable, then I can transmit on high power and it works. So I use my hand as a shield. Well, so what I did is I ended up getting one of those fascia mounts for a house for a small dish. So 14 inches high. So I just raised the antenna 14 inches up above the radio. No more problem. And I might actually pass RF exposure now because it's high enough up that it might go over my head.
So Scotty, I thought you could have a big, long, in-fed wire. Only trouble is if somebody drove over it. Yeah.
Yeah, that's the problem on the bike path. You know, you got walkers and bikers, and they could step on it, and that wouldn't be good.
It works for aircraft.
Yes.
You just have to have enough resilience and enough power in your stroke, you know, to just pull it right out from under them if they step on it. But they do occasionally have like the ASU police drive their cars up there or their Jeeps. And if the Jeep ran over it, there's no way you're gonna pull it out from under. But the guy at our flea market, he used to go around on 17 meters. He had an aluminum frame backpack with a 17-meter whip, and he dragged the counterpoise. Oh. And he would talk all over the place with, he'd maybe run 10 or 15 watts, not very much. But he did drag a wire, and he dragged that through the Hamfest, and just let people not step on it.
So kind of nailing those batteries. Make sure you do put it on YouTube.
Yeah, but I got to look them up and see what I'm getting myself into here. I mean, maybe it's a little like maybe I should do it outside on the patio, you know, over the flagstones, so like it can't burn itself down.
Or get noxious fumes in the house.
Or noxious fumes. Sulfur doesn't sound very good to be inside. So the lithium will be responsible for igniting the sulfur, and then you'd have lots of fun. Because I have a ceramic tile barbecue indoors in the kitchen that was built here before I built this house. I moved into this house, and it's all ceramic tile and fire brick. So I thought, well, this is a perfect place to charge batteries because they caught on fire. It's got a chimney above, and it's got ceramic tile below, so you're not going to melt anything. Fire brick, you know, like cement block, fire rated cement block. But so I don't care. I charge the battery for my bicycle in the nylon backpack that's on the trunk back that's on the bike. So if that ever caught on fire, that's it. I mean, it's burns its way down to the ground. Anyway, so there's a possibility we might get excited on ARIA 10.
Yes.
And I still have the outstanding thing to get the network license up. I've kind of dropped the ball on that. I want to get back on that because the FAE offered to give me a temporary license so that we could get one up immediately. And we'd have 30 days or 60 days or whatever. So then people like Tom could actually use a real full seat license instead of the free license. And with the ARIA 10, you're going to have to do that because the ARIA 10 is not supported with the free tools. So we were going to have to do that. So that's definitely on my radar here, and I've got to get moving and get some of these things done. That's going to require a grant because we're going to have to pay for the license. So, but I think that's exactly the kind of thing that ARDC would be interested in doing, is funding I mean, it's not really a public license, but it is I mean, if you've got a project, talk to us, and there's no reason why we'd say no unless we got like 50 people that all wanted to do projects and we couldn't support them all. But the interesting thing was AMSAT did this back 10 years ago, maybe. They had 2 seats of ORCAD and they had 2 seats of PADS, and nobody ever used them because they never published them. They were publicized it.
Yep.
So nobody knew that they were available. I only found out, I don't even remember how I found out, but I used the PADS license a few times, and then they decided not to renew it. So now I have a PADS design all done, and I can't do anything with it because I don't have the license anymore. So Them's the breaks.
Question for Dave or Jules or someone. When I'm putting in the magnetometer in the pipe assembly, how do you seal the conduit? Do you use silicone or do you use PVC cement?
You're sealing the conduit to what? To itself? Are you gluing lengths of conduit together, or I'm not sure.
Yeah, the conduit that the magnetometer is in and all those caps.
So
how do you,
all these pieces?
Yeah, all of those pieces. What are you doing?
Okay, the PVC. Those pieces you can glue together with regular PVC cement. However, the end caps,
this guy,
right, you should put on with a silicone rubber.
So you can glue this joint here, this joint here,
right,
and that there with whatever you're going to put the bulkhead onto.
You probably the top one you probably also want to use silicone rubber on, because then you can pull that out and you can have access to then remove, if you need to, the extension cable that goes into the connector on the other side of the T.
Because all this is the level anyway, right?
Yeah.
Right. So if you use the PVC cement, then you can never change it.
Right. You glue the long tube to the T with PVC, and actually everything else you can do with silicone rubber.
Okay.
Definitely the bottom cap, and then give a good, once you glue smear some PVC or some silicone rubber on the pipe itself, twist the cap on, or you can put some inside the cap as well, twist it on, and then put a bead around the joint between the pipe. In other words, the top surface of the cap and the pipe, put a bead right where Scotty's pointing now. Put a silicone rubber bead around that as well.
Okay.
And let it sit overnight.
But you want to twist it on real tight, right?
Yeah.
I would recommend testing it too. If it leaks, it's...
Yeah, you have real world experience with it leaking, don't you?
I had one that leaked and...
It destroyed the board.
Yeah. It was the lines with voltage all turned green.
They turned green. Yeah. The interesting thing was, on that board, one of the caps was sitting on its side.
Yeah.
So I don't know how that happened, but just water. But it was an interesting board.
And then do you recommend putting insulation in the top right away?
Yeah, probably a little plug of insulation in the top, but I'd also, if you have some packets of silica gel, thank you. Yeah, if you have some packets, drop a few in there, then put the insulation on top of that. That'll break any circulation, any vertical circulation.
So that's a good argument for leaving this cap not glued in tight.
Yeah, right. So
you put stuff in here.
Yeah, I mean, seal it in well with silicone rubber.
You don't want water running down.
Right. But you don't want to, again, you're going to seal that top cap with silicone rubber. You can twist it off. The silicone rubber will not be a permanent joint like the PVC.
So when you seal it with silicone, how hard is it to twist it off then?
Very easy. Well, when I say very easy, you take a large pipe wrench, and it's the easiest thing to do, and put it on and give it half a twist, and you're ready.
Okay, and then it breaks all of the RTV, and then you can pull the thing off. Okay.
Yep.
And I think what Jules mentioned is attaching the long pipe to the top T with PVC cement.
Yes.
Right. So this joint here.
On my first version, I just did everything in silicone, and that was perfectly watertight and satisfactory. And then I wanted to rotate it 90 degrees to test something about, and so I turned it, and I didn't realize until after I had run my experiment that the T had just twisted, and
so you broke the seal then.
Yeah,
I broke that seal there.
And I mean, it wasn't a water issue because it was above grade and
it was mechanical.
Moving it. Yeah. But if you do want to align the magnetometer, and after sitting a few weeks in the ground, it gets pretty tight to turn.
It does.
When I finally got around to aligning my magnetometer as I was like a good boy was supposed to, according to the directions. I had to use a pipe wrench to actually start turning it, and that, then it loosened up, and I could.
So would you glue this in with PVC cement too? The cap.
No.
Use the RTV on that.
I would. I mean, you could use PVC if you wanted to on that one, but
of course you couldn't get at the nut on the inside. Then even if you might be able to get through it.
Well, not really.
If you want it, here, right?
Yeah.
Not down here. It's way up here.
There's no reason why you can't, because it doesn't take a lot of torquing when you put that connector on, as long as you again push it in so it's tight when you silicone rubber it, and then get a good bead of silicone rubber around the rim. And the problem that Dave ran into, once that pipe sits in the ground for a while, the length of that 2 or 3 feet that's in the ground, whatever, develops a fair amount of adhesion to the soil. So when you twist the pipe, it's not a problem at the cap at the bottom. That's not going to break free, but there's a fair amount of torque you have to apply to the pipe to break it, so break that adhesion, so you can actually rotate it more freely. And that's what Dave found out once it was in the ground for a few weeks.
If you break the T loose, you should just make sure you inspect it again and make sure you re-silicone it if you're gonna.
Yeah, but it's a good idea to PVC that T. It doesn't make anything any more difficult than assembling the rest of it or disassembling it when you need to. But it gives you the mechanical integrity for that particular joint.
And this is only a 2-foot piece.
Yeah.
That I've got. This is a scrap.
Mm-hmm.
They had 2-foot pieces and 10-foot pieces, so I opted for the 2-foot piece. Experiment with.
Sure.
And besides, out here in Arizona, it really never. I'm more worried about it getting too hot than too cold.
Right.
Yeah, with my VLF antenna, what I did was, with the recommendation of Jules, is that the top cap is only sealed with silicone, and the bottom adapter, the series of adapters that I use, that is plastic welded to the pipe. And for water PVC, you're supposed to use PVC primer and PVC cement. So that's what I use with mine. If you remember the picture of my antenna from my Tapper presentation, there's there's a adapter fitting that changes size, and then there's a bushing with a threaded end, and both those are PVC cemented and primed, but that's just attached to the length of the pipe with friction, and it's sealed with silicone. So for here, just like everyone is saying, I would highly recommend is that you use PVC cement and primer on the one end of the pipe and the T, and just use sealant for everything else.
Yeah, I deliberately try to not use multiple adapters because, first of all, you get multiple joints you have to seal. And second of all, it seems like every adapter costs $2. And big ones are more, little ones are a little less. But if you put 3 adapters in here, you're going to have $6 worth of PVC parts.
Yeah, the pipe is cheap compared to the adapters.
Its pipe is cheap compared to the adapters, and so don't use any more than you have to, because we want to keep the kit as cheap as possible.
And you obviously can, you can tailor the pipes and adapters to your particular situation. I mean, currently, these are designed to have that head above ground because of my dogs, and they would just rip the magnetometer out of the ground and chew the wire. So I have it all underground in a sprinkler little vault little plastic
little
sprinkler vault,
box.
and it's been flooded completely multiple times and has survived. I mean, the third one may get it, but it did end up being completely waterproof, at least for 12 hours while being flooded.
Yeah. Well, there's no reason why you can't make it completely waterproof if you just take a little bit of care, because between the PVC cement and the RTV, it is waterproof if you cover all the cracks. What I'm interested in is the gland nut. That's the hard one. To make sure you got that torqued down enough to keep the water out on the wire.
Yeah. If
it was completely underground, that's the part that would scare me the most. The PVC joints, I think you can make waterproof, especially at almost zero pressure.
Well, and not that anyone wants their magnetometer to be flooded, but if you own a home, having your magnetometer get flooded is the least of your worries when it comes to major catastrophes.
Like your basement being flooded, right?
Yeah.
Well, the other thing on the gland nuts, Scotty, you can take silicone grease, dielectric grease, smear everything on that. And then when you screw it together, that'll prevent water intrusion through the threads and through the crack in the nut. You don't have to use silicone seal on it, but a silicone grease would be all required.
Between the wire and the cap, you could even use the RTV type seal.
Yeah, you could do that too. Sure.
Seals off. Yeah.
Yep. The main thing is if there's a differential pressure that exists between, let's say for example, the inside of the pipe is very cold, and you got a lot of warm water coming on the outside. There could be a differential pressure that might allow water to intrude, depending upon how good the seal actually was. But that's going to be a very, very, very unusual circumstance. Most of the time, the groundwater is going to be cold, and you won't have that differential problem.
Once you have more problem with condensation, which is why you put the silica gel in there.
Right, and typically you want to also seal everything up on a day that's not the most humid one in the year, but wait till it's a reasonably dry day and then seal up everything, because that'll guarantee you have the least amount of moisture in there to begin with.
In Arizona, that would be like
every day of the week
until March 31st.
Right.
Well, you can buy those. You can buy sodium silicate pouches that are probably big enough to, not the little ones that come in pill bottles, but that are about this big or so. On Amazon, you can buy bunches of them, and they're cheap.
Yeah.
If you're looking at kitting these things up,
you save the ones that you get out of packages and don't eat them, right?
Yeah. But those are too small to,
So is it true that you can reactivate them by baking those at like 200 degrees for?
Yeah. Yes.
Yeah, actually, you can do it in a microwave for a lot less.
Okay.
I've got some hearing aid things that are to dry, keep hearing aids dry, I guess. And it's a about that, a little plastic.
But the ones you're talking about on Amazon are packaging. You don't dump the beads in there. You put the package in.
No, right.
Yeah, well, yeah, it's a whole package. Yeah, but these things can be redone as 20 seconds in a microwave, and they're pretty well drive off the moisture.
So you get the ones that turn pink when they get wet. So
you can get the ones that have like a little cobalt chloride or something, some indicator in them.
Well, folks, I gotta go, so I'm gonna say 73.
Yeah, same here. It's
same here. 7-3, everyone.
See you next week.
73.